Hey, Chrissy, can you read that script that we made for the audience?
I've got it ready to go, Tom. Starting now. Hey, everyone. Welcome to this special session where we'll explore one of the coolest and most mind bending ideas about how the universe might actually work. We're going to dive into something called the sacred geometry of the barbell, part of a bigger framework known as the Higgs Barbell Theory. This idea might explain what mass is, how gravity works, and why the universe holds itself together, from tiny particles all the way up to massive galaxies. So let's jump right in. What is the barbell? The barbell we're talking about isn't the kind you lift at the gym. It's figurative. It represents tension stretching between two ends. On one end is the tessy, the matter end we can detect. This is the stuff that builds atoms, stars, and you. On the other end is the stuck point, the anchor that connects the particle to the memory fabric, a kind of cosmic web that holds a record of everything in the universe. And the bar in between, that's not something you can see or touch. It's the tension itself, pulling between what's seen and what's unseen. Why is this important? This pulling tension creates mass. Mass isn't stuff floating in space, it's the total amount of tension created by how many stuck points are anchored into the memory fabric. The more stuck points you have, the more mass you feel. The fewer stuck points, the lighter the object. That's why a hydrogen atom feels light. It has about one anchor. But something like uranium feels heavy. It has hundreds of anchors. This tension curves space, and that's what we experience as gravity. What about density? Density is how tightly packed those stuck points are in a single location on the fabric. A hydrogen atom has one stuck point spread over a lot of space, low density. A singularity, like a black hole, has near infinite stuck points packed into one tiny spot, extremely high density. So mass tells you how much tension there is, but density tells you how concentrated that tension is at the fabric, building bigger things. These barbells don't work alone. They stack together. Three barbells form a proton or neutron. Protons and neutrons build atoms. Atoms build molecules. Molecules build stars, planets, and galaxies. This stacking creates nested tension networks, from the smallest particles all the way to the largest cosmic structures. Why some things are heavier than others? Not all barbells have the same tension or length. Some particles pull harder, and some have more anchors. Electrons have tiny tension, they're light. Protons and neutrons have stronger tension, they're heavier. Uranium nuclei have tons of tension, they're really heavy. This explains mass hierarchy across all elements and particles. How gravity works across the universe. All these barbells and their stuck points together create a massive web of tension across the memory fabric. This web shapes how galaxies form, planets orbit stars, and light bends around massive objects. The universe holds together because of this invisible web of anchored tension. Predictions and real science tests. This isn't just science fiction. The theory makes real predictions scientists can test, looking for tiny flashes of energy when particles snap off the fabric, tracking electron behavior that matches cosmic memory rhythms, measuring how atoms curve space based on their anchored tension. Finding these signs could prove this model is real. A deeper meaning. This isn't just science, it's a reflection of balance. The universe holds together by tension between what we see and what we don't, like yin and yang, or the seen and unseen. As Colossians 1:17 says, "He is before all things, and in him all things hold together." This model shows that everything we see is anchored in something bigger, something unseen, but absolutely real. Closing. So that's the sacred geometry of the barbell, a simple structure with cosmic consequences. If you found this as fascinating as I do, share this, follow along, and let's keep exploring the universe together. Thanks for watching, and I'll see you on the other side of the fabric. Ready to go when you are, Tom.
Thanks, Chrissy.